Namaste everyone, hope all of you are well. Till yet, in all the 5 lectures of this equilibrium chapter, class 11, chapter number 7, we have discussed about, first of all, what is equilibrium state. When the backward reaction and forward reaction, both the rate becomes equal, that state is called equal state. And then we have discussed about equilibrium. After understanding what is equilibrium, we have moved towards the rate of reaction is directly proportional to the concentration of reactant and products, as we have taken the forward reaction and backward reactions constant ratio, and we have directly put a rate constant K is equal to Kf by Kb. Kf means forward reaction constant and Kb means backward reaction constant. We have studied these all the things. After then we have discussed about equilibrium divided into the two parts, physical equilibrium and chemical equilibrium. Chemical equilibrium in the Lecture-6 principle, according to that we have discussed about the concentration, we have discussed about the temperature, we have discussed about the pressure, and in physical equilibrium we have discussed about the phase transformation, solid to liquid, liquid to vapor, and vapor to solid, means how the phase transformation. After then we have discussed about dynamic equilibrium, and then we have come towards the point how to calculate the numericals. The lecture number 5 was everything about the numerical. Hope all of you have understand till that topic. In this topic, means today's topic, our this chapter equilibrium, lecture number 6, you can see. Today we are going to discuss, after the numericals, the little bit things were left to make you understand that with the types of reaction, that was homogeneous and heterogeneous reaction. See, there's nothing, no need to worry at the initial video only. Means if I talk about the lecture number 1, in the lecture number 1 only I have talked that how many types of reactions are there, and in that reaction I have divided according to the, first of all I have according to the phase transformation or according to the physical state, that's solid, liquid or gas, these three physical state. According to that only, in the first video I have talked about the homogeneous and heterogeneous. Just suppose if I talk about a heterogeneous mixture, here you can see that calcium carbonate, it breaks down into, this is R1 and R2, calcium carbonate and carbon dioxide. You know very well the calcium carbonate is in solid state, calcium oxide is also in solid state, and carbon dioxide is in gaseous state. So you can see here the reactant has broken down into two different physical states. This is solid and this is gas. So you can see this both the state, means if I talk about this both the physical state, then both the physical states are different. So this will be known as heterogeneous equilibrium. What it will be known as? Heterogeneous equilibrium. Now if I talk about, after understanding the concept of heterogeneous, if I talk about the homogeneous, then can you tell me what will be the homogeneous reactions? I hope homogeneous equilibrium you know very well that if I talk about CH3COO C2H5, CH3COO C2H5, can you tell me what is this? Ester, yeah? So now here, if I talk about how it will be break down, can you tell me? The equilibrium reaction, CH3COO, yes, CH3COOH and C2H5OH, right? Means if I talk about, then it will be break down into acetic acid and ethanol, right? Or here the reactant is also in the aqueous state and the products are also in the aqueous state. So means when the reactant and product both are in the same physical state, that is called homogeneous equilibrium. Means this is an equilibrium reaction, so we can say it homogeneous equilibrium, right? Equilibrium constant in the gaseous State I have already discussed that if PV is equal to nRT, right? PV is equal to nRT, and we have discussed that P is equal to N by VRT, right? Am I right? Yes or no? P is equal to N by VRT. We have already discussed here. P is pressure. The SI unit of pressure is Pascal. N is the number of moles of the gases. V is the volume, whose SI unit will be meter cube, and T is the temperature in Kelvin. Therefore, N by V, which is expressed, that is mole per meter cube. If I talk about the concentration, then C will be the concentration. So instead of N by V, we can write P is equal to CRT. This C is N by V, that is concentration, number of moles per volume. Right? Now, many times we have also discussed that in the Cp and Cv relation, Cp is equal to Cv RT to the power delta Ng. You may have heard this reaction because in the previous lectures I have already informed you that Cp is equal to Cv nRT, right? So you can understand. Similarly, if I talk about here there was a constant, then equilibrium constant Kp and Kc. Since we are discussing about the reactant and product, so here you can write it that Kp and Kc, Kp is equal to Kc RT delta Ng. Already I have discussed these all the things in the previous video, if you may have remembered that. Kp is equal to Kc RT delta Ng. These all things already we have proved in the previous lectures. If you may have remembered, if you have not seen those videos, then go through my channel, just open some links. You will get lecture 1, lecture 2, lecture 3, lecture 4 and lecture 5 of this chapter, equilibrium, lecture 1, lecture 2, lecture 3, lecture 4, lecture 5. Now delta N is number of moles of gaseous product minus number of gaseous reactant in a balanced chemical equation. Kp is the value of Kp pressure should be expressed in bar because the standard state for pressure is 1 bar. We know very well the unit 1 Pascal is equal to 1 Newton per meter square and 1 bar is equal to 10 to the power 5 Pascal. So for any reactions we have already discussed that how the rate constant means whatever the examples were given in our NCERT textbook, that all the examples we have discussed in lecture number 5. And hope all of you have understand also that examples. If you want to discuss any example, then here 7.4, 7.5, that the concentrations were given and we have to calculate. So slowly we have done this. Or I hope that in the previous video I have already done these all the things. Now after understanding, there are two main things that what are the uses of this equilibrium reaction, means you can say the applications of equilibrium reactions. Why there is a need of equilibrium reaction. So in this video especially we will discuss about the uses of equilibrium constant. First of all, expression for equilibrium constant is applicable only when the concentration, the reactant and product have attained the constant value at the equilibrium state. Constant value at the equilibrium state means the rate constant of reactant and the rate constant of product, when they both have reached to the equilibrium state, then you can say that really this reactant and product both they have reached to the equilibrium state. This is the first applications of this equilibrium constant. Second is the value of equilibrium constant is independent of initial concentration of the reactant and product. Here they are not binded that this should be binded that the concentration should be only this. Here the concentration is independent. As you will increase the rate constant, similarly the concentration is also going to increase. The third point if I discuss about equilibrium constant is the temperature dependent. One unique value for a particular reaction represented by a balanced equation in a given temperature. So first of all you should remember that what are the things which increase the rate of reaction or decrease the rate of reaction, that is temperature, pressure and concentration, as we have discussed in the Lecture-6 principle. So if I talk about the temperature, if we increase and decrease the temperature, you know very well that is going to affect the rate of reaction. So temperature is dependent on this equilibrium reactions constant. The equilibrium constant for the reverse reaction is equal to the inverse of the equilibrium constant for the forward, and the equilibrium constant K for the reaction is related to the equilibrium constant of the corresponding reaction whose reaction is obtained by multiplying or dividing the equation for the original reaction by a small integer. See, first of all, if I talk about K is the reaction constant, K is equal to 1 upon K inverse. They both are equal. Either reactant and product, if you talk about how they became reactant to product and product to reactant in the forward reaction. So that's why I have given here that you should understand why there is a uses of equilibrium constant, and these all the things. Hope all of you have understand this concept in the previous video only. The main thing after understanding this equilibrium constant, total these three parts of this chapter, if you go through the NCERT or if you go through the IIT JEE, then there is a need to understand that what are the things which we have to study. When we will move towards the chemical kinetics in the 12th standard, that time we will discuss about the rate order. First order reaction, second order reaction, third order reaction, what will be the value of half lifetime period. These all the things we will discuss in the chemical kinetics. This is the third part. In this 11th standard, we have to discuss two things. First one is chemical equilibrium and second is ionic equilibrium. Ionic equilibrium, if I talk about, before starting the ionic equilibrium, you can just go through your NCERT that there is one more thing, predicting the direction of the reaction. When you are giving some of the direction, that it is the forward reaction or backward reaction, that is the main thing, that you should predict those reactions, that how they are formed, right? Means you should know the concentration, reaction quotient, and the concentration constant reactions. So sometime already I have told you about that if we take any reaction, just suppose that we are taking A plus B equilibrium C plus D. Okay, here the A molecules, B molecules, C molecules, D molecules. If I talk about the constant, then the concentrations of product upon concentration of reactant, right? Concentration of product upon concentration of reactant. So as you have seen, and if I talk about the quotient, can you tell me what is quotient? Anyone? What is quotient? This is a new term, you may have heard, reaction quotient. The equilibrium constant helps in the predicting the direction in which the given reaction will be proceed at any speed. For this purpose, we calculate the reaction quotient. The reaction quotient is denoted by Q with molar concentration, and Qp is the partial pressure concentration, which is defined in the same way the equilibrium constant Kc, except that concentration in Q are not necessary equilibrium values for any general reaction. But if I talk about Qc, and if I just here if I talk about the concentration constant, and here quotient concentration. So here sometimes, as if I say about that, what is the relationship between QC and Kc? QC is greater than Kc, then the reaction will proceed in the direction of reactant. Means if I talk about the quotient constant is greater than the rate constant, then it will be backward reaction. And when the quotient constant is less than rate constant, then there will be a forward reaction. And when QC will be equal to Kc, that time you can say the reaction mixture is already at the equilibrium. See, means here if I talk about that R1, or you can say this is the forward reaction and this is the backward reaction. So when A plus B is equal to C plus D, means this is your forward reaction, and C plus D is equal to A plus B, this is your backward reaction. And when A plus B equilibrium C plus D, so three states are there, means this is your forward reaction, this is your backward reaction, and this is your equilibrium reaction. So here in this three stage, QC in the equilibrium it will be equal to concentration constant. But if I talk about greater than and smaller than, then remember, dear student, QC will be less than KC in forward reaction. Less than KC. Less than KC means KC will be greater. Okay? And when the KC is less than, so here you may understand these 3 points. This is forward reaction. This is backward reaction. And this is equilibrium reaction. Okay? So the things which you have seen in this bracket means equilibrium constant if I talk about, the rate constant if I talk about. So here what is the relationship between the equilibrium constant and the rate constant, or quotient reaction or constant reaction. Hope all of you have understand. This will give the direction. And if I talk about the equilibrium concentration, so we have to write a balanced equation for the reaction, make a table or list the substance involved in the reaction, means initial concentration, change in concentration, equilibrium concentration. Substitute the equilibrium concentration into the equilibrium equation for the reaction for solving X, and we have to do the mathematical solution that makes chemical sense. Calculate the equilibrium concentration for the calculated value of X and check the result. Here if I talk about one question, let us discuss NCERT problem number 7.8. So you will have a great mind that really some studying something which will be related to that. Means you have to calculate. Here question is 13.8 gram of N2O4 was placed in a 1 liter reaction vessel at 400 Kelvin and allowed to attain equilibrium. The total pressure at the equilibrium was found to be 9.15 bar. Calculate Kp and Kc and the partial pressure at the equilibrium. So I hope that you have understand the reaction. In this question we have to find Kp, Kc values. How you will find Kp, Kc values? I am showing you, it's very easy, no need to worry. First, the things which you should remember is this equation. Now in this question, here already given N2O4, equilibrium NO2. This is your equilibrium reaction. Is it equilibrium? Yes or no? First of all tell me, the reaction is balanced or not? Yes. Both are in the gaseous state. Okay. Now what the things are given in this question? So we know very well that ideal gas equation PV is equal to nRT. Right. The things in the question which is given is volume is 1 liter. Okay, number of moles you have to calculate. So let us write what the things have been given. You can see in this question, volume is equal to 1 liter. Okay. Second is molecular mass of N2O4. Molecular mass of N2O4 is equal to 14 2s are 28 and 16 4s are 64. 64 plus 20 is, that is 92 grams. And number of moles is equal to given mass upon molecular mass. So given mass in this question is 13.8 gram divided by 92 gram. So the answer will be 0.15 gram. And rate constant R is equal to, everybody knows, 0.083 bar, right? And temperature in the question is given 400 Kelvin. Okay. What you have to calculate in this question is pressure. Okay. After then, as you calculate the pressure, then you have to calculate in equilibrium reaction that what will be the value of Kp and Kc. It's very easy, dude. No need to worry. First of all, let us calculate. Okay. Now come to the question. PV is equal to nRT. Okay. Is it okay? Yeah. So you know very well, P is equal to N by V RT. N is given how many moles? 0.15. R value is 0.083. And temperature is 400 Kelvin. And if I talk about volume is 1 liter. Right? Is it right? Yes or no? Just tell me. Yes or no? Yes, it's right. Now if I talk about that what will be the value of pressure, just multiply 0.15 into 0.83 into 400. So here you can see that 15 upon 100, 83 upon 1000 and 400 upon 1, or directly 1 liter. 0 0 cancel. Okay. Now 15 4 is 60 into 83 upon 1000. 0 0 cancel. 8 6 is 83. It's not 80. It's 83. Sorry, 83. So here 6 3s are 80 and 6 8s are 48 plus 149 upon 100. You can say that 1 0 has been cancelled. So it will be 4.98. What is this 4.98? It is a pressure. 4.98 bar is a pressure, right? Got it? Now you have got the value of pressure. Now we have to calculate at the initial pressure. Now just suppose this reaction N2O4 gives 2NO2. Okay? So here you can see it's a 2 mole, 2x it is, at the initial pressure. Initial pressure means, can you tell me? Startingly what had happened when the reaction was at equilibrium state, at initial pressure, when this question is N2O4 was 4.98, that time it was 0. Okay. Now, here I am talking about, we have to calculate 4.98 minus x is equal to 2x. Here, if I talk about 2NO2, then you can say that why it's 2x bar. So I will now tell you, because we are dividing the partial pressure, in the question it's already given that the total pressure at equilibrium it was found 9.15 bar. Yes, 9.15 bar. Now what you have to do, total pressure means here this 2x and this means total pressure P total is equal to 4.98 minus x plus 2x. And here it's given in the question how much it is? 9.15. 9.15 bar is equal to 4.98 minus x plus 2x. So it will be 9.15 minus 4.98 is equal to x. Right? So you know very well x is equal to 15 minus 8 7, 10 minus 9 1, 8 minus 4 4.17. So what is this 4.17? It's total pressure. What is this? 4.17 is total pressure. Now you have to calculate about the pressure of N2O4 and pressure is of NO2. Pressure of NO2 and pressure of N2O4. So here, if I talk about the pressure of N2O4 is equal to 4.98 minus 4.17. That is equal to 8 minus 7 1 and 9 minus 1 8. 0.81 bar pressure it is of N2O4. And if I talk about the pressure of NO2, means pressure of NO2 it's 2NO2x, so means 2 into 4.17, that is 8.34 bar pressure. This is the pressure of NO2. This is the pressure of NO2. Now the main reaction which we have to write, that is Kp and Kc. First of all, how we will calculate the pressure constant? Pressure constant is equal to the pressure of Concentration means pressure of product upon pressure of reactant. Now pressure constant you have to calculate. So let us calculate the pressure constant. Now pressure constant is equal to Kp is equal to. Here you can see that is concentration of product will be here 8.34 to the power 2 upon the reactant N2O4 0.81 means 8.34 into 8.34 upon 0.81. So when you will multiply 8.34 into 8.34 and you will divide, then you will get 85.8 C. That is 85.8 C. Or you can write 85.87 or you can write 85.8 also, no problem if you want to write. This is the pressure constant. And now if you want to calculate the concentration constant Kc, Kc is equal to what? So can you tell me what is the relation of Kc is equal to Kp? Kc is equal to Kp delta, or you can write RT delta Ng, delta Ng RT. Can you write this? Yes or no? Just tell me. We can't write. Kp is equal to Kc we can write. This we can't write. Here we have to write Kp is equal to Kc delta, and so we have to calculate Kc. Kc is equal to Kp upon RT delta Ng. RT delta Ng. Can we write this? Kp value we have already got it. That is 85.87 upon R value is 0.083. T value is 400. And what is the value of delta Ng? Can you tell me? How many number of moles we have calculated? 0.15, right? So you can write this 0.15 as power 1 because this is the RT to the power Ng, right? So here instead of 0.1, so we can write here 85 upon 85.87 upon 4 3s are 12 and 8 4s are 32. 0.032. Right? Can we write this? Yes or no? Yes, we can write it. When you will divide this, so the 3.22 sorry 32 point, yeah, 32 point, okay, 8 4s are 32, yeah, 32.2. When you will divide 85.87 by 32.2, the answer will be 2.6. So this is the value of Kc. This is the value of Kp is 85.87 and Kc is 2.6. So whenever you get this type of question, no need to worry. What is the question? Remind that question. Whatever the things are given, try to solve those things. So I was coming to the point of ionic equilibrium. Before ionic equilibrium, there are few things which you must remember. Relationship between the equilibrium constant K, reaction constant Q, and the Gibbs energy G. What are the formula? There is no need to worry. According to the Lecture-6 principle, the change in any of the factors that determine the equilibrium conditions of a system will cause the system to change in such a manner so as to reduce or to contract the effect of change. So if you want to write, it's simple. Delta G is equal to delta G standard plus RT ln Q, where delta G standard is Gibbs energy, and delta G is equal to delta G RT ln K. Delta is equal to minus RT ln K. Ln K is equal to minus delta G standard upon RT, and K is equal to e to the power minus delta G standard upon RT. So this is the relationship between the equilibrium constant K reaction, quotient Q, and the Gibbs energy G. So as we have seen here, the things which I have described. So if you want to write these things, then you can write. First of all, after understanding the concept, you should write those things which you are not understanding. Now you have to write the relationship between Gibbs energy, equilibrium constant, and quotient equilibrium. Right? So what we will write, first of all, speak about those things what you want to write. Okay? So here you can see that already it's given. Delta G is equal to delta G standard plus RT ln Q. Delta G is equal to delta G standard plus RT ln K. Right? Can you write this? Yes or no? First of all, tell me. This equation is only known as the relationship between the Gibbs free energy, the equilibrium constant, and the, if I talk about, so standard Gibbs energy. Standard Gibbs energy. So what will happen? Can you tell me? Delta G minus delta G will be delta G only. If I talk about, if I take this side, so delta G standard is equal to minus RT ln K. What is the value? Minus RT ln K. And if you want to find the value of log K, just suppose that if you want to find the value of log K, then nothing minus delta G upon. If I just suppose here, if I want to find the value of log K, what is the value? Minus delta G standard upon RT. Right? Can you write these things? And now if I remove log, then what should I write? K is equal to exponent to the power. Means if I am removing the log only, then definitely K will be equal to e to the power minus delta G standard upon RT. So this will be the constant value. Got it? Now you have to understand that when the Gibbs energy is less than 0, it is positive, it is a spontaneous reaction. And when delta G is greater than 0, means it's negative and it is implies to a non-spontaneous reaction. So here one question is for that also. What are the factors affecting the equilibrium? That factors already I have talked about in the Lecture-6 principle. Now the effect of concentration, effect of pressure change, effect of inert gas, effect of temperature change, and effect of the catalyst. These are all the things already I have discussed when I have informed you about the Lecture-6 principle. So dear student, wherever you are studying, see I have taken note through the NCERT. Startingly I have started with some of the new notes, means you can say it was started with the help of beginning, that from where you should connect with the equilibrium. So I have taken the types of reaction. After then slowly I have moved toward the reversible reaction, and in the reversible reaction I have input equilibrium, and then I have discussed slowly rate constant. After understanding the concept of rate constant, then I have shown you molar activity, means how you will understand this rate of reaction according to the product and concentration. Slowly after moving these all the things, now the last final step of this chemical equilibrium was moving towards the rate constant, how to determine the rate constant. Then the main thing came Lecture-6 principle. The Lecture-6 principle described about the concentration, change in concentration, change in temperature, change in pressure. In physical equilibrium and chemical equilibrium, then homogeneous equilibrium, heterogeneous equilibrium. Then after that the relationship between the Kp, Kc, then Gibbs free energy, equilibrium constant, equilibrium, you can say equilibrium quotient and constant, both relation, Gibbs free energy relation. So whenever, see, everything should not be mixed up. Whenever you are learning point to point, then point to point should be attached. That whatever was the first step, each second step attached to it or not. Third step is attached to it or not. So dear student, if you have any problem in this lecture number 6 video, then please drop it out into the comment box section. Definitely all the doubts will be solved in the next video. That's all for today. Thank you very much. Hope all of you have understood the concept. If you have enjoyed, and don't forget to like and subscribe the channel. share this video with your friends so they can be also getting the concept. That's all for today. Thank you very much.